Man, I can't wait to dig into that ice cream.
Me too. Where did the ice go?
I'm sure it just dissolved.
But the bag isn't even wet. How can ice disappear into nothing?
That's because I used dry ice, not regular ice. It's not frozen water.
Really?
Yeah, look, come on. Let's put this away. I have an experiment I can show you how. No ice cream.
Okay, okay.
How does dry ice differ from regular ice? How does dry ice act on a hot day compared to a cold day? Does dry ice stay frozen in a freezer? Let's find out.
Hi, welcome to Moon Kong Simple Science. Do you love ice cream? Well, I sure do. One thing I noticed is when I buy ice cream, they put little bags of ice in with my ice cream so it doesn't melt. But did you know that ice is not the same as regular ice? It's actually called dry ice. Well, today I have some fun experiments to show you the differences between regular ice and dry ice. Okay, let's get started with my first experiment. And for that one, I have a piece of dry ice. Let's take a closer look. And what I'm going to do is take an ice cube and put it in our other cup. And let's look at that. Okay, what I want to do is wait a little while to see what happens. Okay, now it's been about an hour, so let's take a closer look at our cups again. Now, in the cup with the dry ice, it's dry. And the one that had the ice cube in it has turned to water. You see, dry ice is not frozen water. It's actually frozen carbon dioxide gas. Okay, let's get started on our second experiment. And for that one, I need a new piece of dry ice. What I'm going to do is hold a heated spoon next to it. You see, I've placed the spoon in a glass of hot water to change its temperature. What do you think is going to happen when I hold that heated spoon next to the dry ice? Let's find out. Can you hear that humming sound? Let's do that one more time. Okay, why is that happening? Well, you see, the spoon is quite hot, and when I hold it next to the dry ice, it causes the dry ice to change over to that invisible gas. Dry ice is just like regular ice. When it's in a warm environment, it will change quickly, like ice will change to water, dry ice will change to gas. That's why when you're outside on a hot summer day, you better eat up that ice cream quickly before it melts. Okay, let's move on to our third experiment. For that one, I'm going to use my piece of dry ice again, but I'm also going to use a cold spoon instead of the hot one. I place a spoon in a glass filled with ice cubes so that my spoon can get cold. Now, what's going to happen this time? Let's find out. Now, it makes a little sound, but not as much as the hot spoon. Why is that? Well, you see, because the spoon is colder, it's having less of an effect on the dry ice. So less ice is converting over to gas. But dry ice is a lot colder than regular ice. To freeze dry ice, it actually has to be placed in an environment at minus 78 degrees Celsius, where regular ice actually freezes at 0 degrees Celsius. So if you take your piece of dry ice and place it in the freezer, the dry ice will still thaw to carbon dioxide gas. Okay, what did we learn today? Let's review. First of all, dry ice is not frozen water. So, unlike regular ice that melts into water, dry ice actually changes to carbon dioxide gas. We've also learned that when dry ice is placed in a warm environment, it will change to gas a lot faster than if it's placed in a cold environment. And lastly, we learned that dry ice has a lower freezing point than regular ice. Dry ice freezes at minus 78 degrees, while regular ice freezes at 0 degrees. Well, that's all the time we have for today. I hope you had fun. See you next time. Bye.